Hey gang, today we want to talk about, is the universe special? Theists will say that it is. They'll point to the fine-tuning argument and say that if any of if many of the physical constants in nature were tweaked in some cases like 1 part in a billion, that the universe as we know it would not work. The laws would just, everything would come down like, kind of like a house of cards. And the atheist scientific response is to say that no, our universe isn't special because it's just one of many. It's one out of a possibly infinite number of universes with an infinite number of just randomly composed configurations. And the theists usually don't know how to respond to that charge, but I feel that I do, and I'm going to share it with you. What I believe is that you have to realize is that what the atheists are saying there is they're assuming that the random variable, which in this case is the particular configuration of a universe, they're assuming that qualitatively that is a nominal variable, which means that all of the instances of a configuration for each universe, like universe A, B, C, here's configuration 1 for A, configuration 2 for B, configuration 3 for universe C, and that they're just nominal. You know, there's just one here, there's one there, there's one there. There's no order to it. But the other type of qualitative random variable is the ordinal variable, and if the that's pretty much it. Like, if the configurations are ordinal instead of nominal, then they can be ordered in some way. So we start looking at the possibility that, because you know, if it can be shown that the chance of one configuration is somehow less than another, then and that they don't all have the same chance. That's another thing. Like, they've assumed that they were nominal, which means that they can't be ordered, and that they all have the same chance, which is a pretty big assumption, considering that let's assume that the universal configurations are ordinal. Now, we can symbolically understand this with an analogy I came up with that's just a deck of throwing cards, or excuse me, a deck of playing cards. And the analogy is imagining opening the box, taking out the cards, and then instead of dealing out a hand, you just throw the cards everywhere. You just say, oh, let's play 52 card pickup. And you throw the cards up in the air, and they all come under the normal laws of physics that apply to our universe, and they just fall randomly on the floor. Okay? I think you can start to see where I'm going with this. What are the chances that they're just going to fall randomly, you know? Like, that's pretty much all they're going to do. And except for every once in a while, you might get two cards falling onto each other, supporting each other over the floor, and that would be pretty rare. That would probably be like 1 in 100 or so. You'd have to do it to find out. Now, what if I asked you, what do you think the chance? Get out your pen and paper, right? No. What do you think the chances would be if of a little house of cards, just some kind of neat little 4 or 6 cards making a house of cards? The chances of that really low, okay? And an unbelievable, like, the least chance is that all of them would like form into a house of cards. I mean, you pretty much have to build that. Like, you have to put everything in a specific spot. So the chances of the entire, all 52 cards in the deck just thrown and then magically, or seemingly magically forming an entire house of cards. Now you can start to see that the chance has to be taken into consideration. Or, yeah, the chance of the degree of order, the order, which is, if you know anything about thermodynamics, it's actually negative entropy. It's like reduced entropy, and that's what life does. It actually is locally reducing entropy, but then it's giving off entropy as exhaust. Okay, so drawing on the deck of cards analogy, we can say that our universe, we can kind of analogously say that the amount of entropy that our universe began with, which is the lowest point of entropy that our universe has ever had and will ever have, because assuming that our universe is closed, then since the entropy in a closed system just increases, we're going towards a state of maximum entropy. Scientists already say that the chances of our universe starting with such a low degree of entropy are really, really small to begin with. And then you couple that with the deck of cards analogy, and you can see that, like, all the randomly scattered, all the different ways that the cards could land on the floor in a scattered manner, that represents all the really likely and low entropy, or high entropy initial states, because the higher entropy you start out with, the less the chances are for life. I mean, even if the quote-unquote configuration of natural laws was exactly the same as our configuration, but you just didn't start out with enough energy in the beginning, then because, like, the final entropy state is absolute thermodynamic equilibrium, and if you look at the Big Rip, it's actually showing that our universe will be stretched to infinity. Like, each particle goes to being an infinite distance away from every other particle. And yes, so you can, that's my response to the atheist claim that the multiverse shows that the universe isn't special. I'm saying that it could very well be special, just simply based on the assumption that configurations don't all have the same entropy, and that the chances of having really low entropy to begin with is much less, making our universe special.